Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Now we continue again estimation method for the difference between two population mean for dependent sample. Okay, previously we already looked into the independent sample. Now we look into dependent sample. Okay, the test we call as PET-T test. So there are three things that you need to find first. You have to calculate the mean PET difference, which is D bar equals to summation of D over N. And then standard deviation of PET difference, SD, equals to 1 over N minus 1 times summation of D square minus summation of D square over N. And then the formula for confidence interval equals to D bar plus minus T alpha over 2 N minus 1 times SD over square root of N. Okay, let's take a look into the example. Okay. A professor of psychology and neuroscience has claimed that music education increases mathematics skill in children. One group of children was randomly selected and given a test on ratios and fractions. They were then given piano lesson twice a week for 4 months, after which they were given another similar test. The table below shows the score before and after the piano lesson. Okay, so the table below gives the score before and after of the children attend the piano lessons. Okay, so this is what we call as dependent sample. Why? Because we have one group of children and then we take the measurement on the children twice, 2 times. Okay, so what should we do first? You have to find the difference for each pair of the sample. Okay, for example, for children number 1, the difference is between 30 minus 35, so we get negative 5, and the value of D square equals to 25. For children number 2, 45 minus 58, so we get minus 13, and the square of minus 13 is 169. You also can do after minus before. There is no restriction. Okay, you can make before minus after or after minus before, and then calculate the summation of D. So for this example, we get negative 43. Summation of D square equals to 609. Okay, then the question is find a 90% of the interval for the true difference in the test score before and after the piano lesson. Assume the populations to be normally distributed. Okay, first calculate the D bar. So the formula for D bar is equals to negative 43 over 9, summation of D over N. So we get negative 4.7778. And then find the standard deviation for the difference. The formula is 1 over N minus 1, summation of D minus summation D square over N. So we get 7.1024. So alpha for this example equals to 0.1. So for T alpha over 2N minus 1 is equivalent to T 0.058. And by referring the table 7, we get the value of T statistic equals to 1.86. And then substitute into the formula of the confidence interval. Finally, we get negative 9.1812, negative 0.3743. Okay, so how to interpret the interval? Okay, since the interval does not passing through zero value, there is difference in the test score before and after the piano lesson. Okay, so you can look the interval value was negative. So it means that before minus, after we get the value are less than 0. So the score before were less the score for after piano lesson.